I'm glad to give you a presentation about our research project. The topic is Advances in Blockchain Security. Now let's move on to the agenda. First, we will give an introduction of blockchain, including explaining what is a blockchain and what property does it have. Then we will introduce some applications that are related to security, where blockchain is used. After that, we will discuss some security risks and threats that blockchain currently have, and their corresponding countermeasures. Finally, we will talk about some future issues that may occur. The first question is, what is a blockchain? This concept is proposed in a 2008 paper called Bitcoin, a peer-to-peer electronic cash system. A block here is defined as a group of data, along with a header containing the hash of the data, timestamp, and so on. The header also contains the hash value of the previous block, which chains them together and forms a blockchain. In the Bitcoin design, blockchain is used as a public ledger. So as you can see, in the picture, data in the blocks is transaction information. Blockchain has many properties. The main one is that it is immutable to modification. Since the blocks are chained by the hash value, even a single bit alteration in a block requires regenerating all the blocks after it. Actually, it's not impossible, but it needs a great computing power and is currently very difficult to realize. Another property is that blockchain provides better security. Blockchain is based on P2P network and its content is visible to all nodes in the network. Each node keeps a copy of the whole blockchain, so even if some nodes go down, there will be no data loss in the blockchain. Besides, information and transactions are cross-checked by all the nodes, so it is very hard to hack a blockchain. Now let's talk about some applications of blockchain that are related to security. First is Enigma, a blockchain-based platform that offers decentralized computation and data storage. Enigma splits the data to be stored between nodes. Nodes can't get any information from the database they hold. The reference of data is kept on a distributed hash table, which can be accessed through blockchain. When data is queried, the pieces will be retrieved and reconstructed into the original data. Blockchain itself does not store data. It mainly handles access control and stores transaction information and records code executions. Blockchain can also be used to mitigate DDoS attack. Here I will explain the scenario. As you can see, there are three autonomous systems as A, B, and C. Assume a host in one of the systems is under DDoS attack. Some nodes have already formed a collaborative defense. The participants of the defense will then store the attacker's IP address in a smart contract. These addresses will be submitted to a blockchain and stored in the next generated block, which takes around 20 seconds. All the autonomous systems that subscribe to the blockchain will receive a list of attackers' IP to block.
As we know, blockchain is based on P2P network, so there are possible attacks may arise. 51% attack is also called majority attack, which is a common attack in the blockchain network. In this attack, attackers try to control more than half computing power on the network, so that they could reverse transaction confirmation and even prevent users from mining the blocks. One issue caused by the majority attack is called double spending. The attackers could generate a private chain and then replace the public one with more than half voting power so that they could reuse the cryptocurrency. So, how does it work? First, there is a green one, which is a public chain running on the network. The attacker generates blocks on his red private chain without broadcasting any information to the network. Then, the attacker spends 1 Bitcoin on the public chain. The public chain records this transaction and broadcasts it to the rest of the network. But The private chain is separate from the public one, and hence it does not store any information about that transaction. When the attacker has more than half computing power, he generates blocks on his private chain much faster than the public one. Therefore, the private chain becomes longer than the public one, and then the attacker starts to broadcast his private chain to the network. And users always follow the majority, so they will switch to the private one and consider it is a truthful one. Now you see the attacker's private chain has replaced the public chain. You can see that in the private chain, there is no record information about the spent Bitcoin. Thus, the attacker could reuse the Bitcoin. Another attack is called CBO attack, where attackers create multiple fake identities and try to fool honest users that they are the truthful users, so that they could control part of the network, such as destroying reputation system.
And now we are going to talk about the quantum computing risk for the blockchain. Before we start the topic, I will make a simple security analysis for the blockchain. We all know that there are two kinds of security for a system: the unconditional security and the computational security. In this part, we assume that an attacker had known all the conditions of the encryption algorithm for each blockchain. Will the blockchain be an security? Let's use one of the most famous applications of the blockchain, the Bitcoin, as the example to analyze. For the Bitcoin, one of the most important security protocol is the proof of work. In this protocol, the system will ask the user to solve a very complex mathematical problem. In the blockchain, the complexity can be expressed as the computing power, whose unit is the hash transform per second, as h per second. As you can see the right picture, the computing power of the Bitcoin system blockchain has been more than 55 million terahash transformer per second. And to be easy to understand what a huge number it is, a calculation will be shown. We'll assume that a normal mini machine for Bitcoin is about 12 TH per second, and which means it's needed more than 4.6 millions machines are needed to have a same hash rate or the computing power as the Bitcoin system. And according to the 51 attack, there are more than 2.3 million machines are needed to control the whole system. It's a really huge numbers of machines, which means a high cost of resource, and it's impossible for a normal computers to break the system in a universe time, which means the whole system is the computational security. However, the things had been changed with the development of the quantum computing. In a quantum computer, a special unit of the calculation which is called as the qubit. Through the superposition principle, it's let the computer beyond the limitation of the binary. As you can see the picture from the Google AI blog, a quantum computer whose name is D-Wave2X can be 100 million faster than the normal computer to solve same problems. Even it still have a high cost of solve problem, and it had to work in a really low temperature. But as the statement before, if a computer power can be developed at this level, in future, the computational security of the system is not a security anymore. The security risk will be heightened. It's called as the quantum computing risk for the blockchain.
So this is how blockchain security looks like, and hope you enjoy it. Thanks.